Good morning, and let me just say that I'm making this video really late. I had a lot of stuff to do this morning, so hopefully I don't make too many mistakes in this video, but I apologize in advance. But we're gonna work on something called composite figures today. So composite figures are just basically a figure that's made up of a bunch of different plane figures. So if you look at any object in your house that's not like a basic either rectangle, square, circle, that could be classified as a composite figure. So another like real world example that always comes up with composite figures is like thinking about a layout in your house. Like your house is probably not just a straight up rectangle. It probably has these like weird nooks and crannies that could make the area a little bit different than just an area of a rectangle. So getting into notes, the reason why we had to go over area and how to calculate area with just like plane figures was because with composite figures, we're basically just going to break these down into all those separate, easy shapes that we know how to find area for. So I think you may have done this in middle school. I'm not quite sure, but we're just going to act like you've never seen it before and go from there. So again, kind of reiterating what I just said, but a composite figure is a figure that can be separated into regions or parts that are just those basic figures that we've been talking about this week. Triangles, parallelograms, rectangles, trapezoids, circles, anything that has a actual area formula that we know, because looking at number 1, I don't know any type of area formula that is specific to this shape, so that's why we have to break it up into the shapes that we actually know how to calculate. So to find the area of a composite figure, you're going to split up the regions. Oops, I don't know why I put it little curly Q. So split up the regions and find each area and then add them together. Whoops, I'm getting ahead of myself. And so by adding them up together, you're finding the sum of all those areas. So I'm going to do all the odds, and then you're going to do the evens. So for number 1, there's 2 regions that I see right away. There's this rectangle region. I'm going to name it 1. And then there's this, it looks kind of like a trapezoid region, and that's going to be my 2. So at the end of this, I'm going to take the area of region 1, and add it to the area of region 2 to find the total. Okay? So for region 1, that looks to be like a rectangle. Now, here's the tricky part with these. You have to figure out what piece of these actually is the rectangle. This one's a little easier because I can already see the length would be 12 centimeters, or the width. Let's call this the width, actually. The width is 12 centimeters, and then the length is 23. So the area formula for this is just going to be 23 times 12 to give me 276. So that's area 1. Now for area 2. Area 2 I said was a trapezoid. So a trapezoid, hopefully you have your sheet out with all of your area formulas. But a trapezoid's formula is 1/2 times the height times the sum of the bases. So I'm going to highlight those bases. So here's one of the bases, and here's the other one. Reminder that those bases are the parallel lines. So one of my bases would be the opposite side from this rectangle. So one of my bases is 23. So I'm just going to write in for this formula 1/2. I don't know the height yet, so I'm going to leave that blank. times, and then my base would be 23, and then my other base is 15, so 23 plus 15. So the only thing I have left to find is the height. Now the height, I don't know the exact height from here to here. I do know that this entire figure is 18 centimeters, and then just this rectangle is 12. So you have to kind of think about, you're going to subtract the 12 from the 18, subtract the rectangle's height from the entire height to just get the trapezoid's height. So 18 minus the rectangle's height of 12 to get a height of 6. So my height is 6. Height, base 1 plus base 2. And so the second area, so the area of the trapezoid, turns out to be 114. And so when I add 276 to 114, area 1 plus area 2, I would get a total area, sorry, this is really messy, of 390. And then we're in centimeters, so centimeters squared. Okay? So going over the steps again, first I divided up or split up the two regions, the two shapes that I could figure out easily. And then I calculated their areas separately, and then at the very end I added them together. Okay, so we had to do a little bit extra work to find the height of this trapezoid, but it wasn't too bad just thinking about subtracting the rectangle. Hint for number 2, before you try to turn it in, this, you would calculate, this could be 1 with this, because together those would make a complete circle. So 1 would be a circle, and 2 would be, 2 is this portion, that would be a parallelogram. And in the circle, they actually give you your radius, so r is 6, so you don't really have to do much for the circle. Parallelogram, you might have to do a little bit more because you have to calculate this distance. But remember that the radius should be the same on both sides, so that should be a good enough hint. For 3, I automatically see 3 regions. So I see a triangle here, 1. I see a rectangle, and I see a circle, or a half circle. So for the area of figure 1, my triangle should be 1/2 times base times height. We want to make sure I actually know all of those things. So my height would come from this portion, this dotted line here. Let's see. I know that, let's actually calculate this one last. I'm going to move on to area 2 because area 2 looks pretty easy. So area 2, no, wait, I'm going to start with area 3. Area 3 is the easiest. Let's go all the way over here. The reason why I'm not doing 1 and 2 is because I really want to know what this part is, my radius, and then that will help me with both of these. So looking up here, this dotted line is connected to the top of this rectangle, so that means my radius also has to be the length of this opposite side of this rectangle. So my radius in this half circle is also going to be 9. Okay, so using that half circle area formula, that's 1/2 pi times r squared. So area 3 has to be 1/2 times r times pi times 9 squared, which would give me an area of 127.23 and then feet squared. For area 2, I'm going to do area 2 next. I know one of my lengths, this is a rectangle obviously, one of my lengths would be 9 feet, and then I'm not quite sure about this entire thing. But what I do know is that this entire figure is 26 feet long. So really I just have to subtract whatever height this circle is. So I do know that the radius of the circle is 9. So if I drew a line from the center to the outer ring, the circumference of the circle, it's going to be 9 everywhere, right? So really we could say the height of this circle is 9. So I'm going to subtract 9 from 26 to get the actual length of this side of the rectangle. Okay? So 26 minus 9 will give me this side length of 17. So to find area 2, I'm going to take 9, so my length, times my width. So 9 times 17. And so area 2 is 153. Then lastly, I'm going to find this triangle, which I named number 1. So I need to know what my base is and what my height is. Well, my base is coming again from that radius of the circle. So my base is going to be 9. So area 1 equals 1/2 times 9. And then my height is coming from something different. So my height, I'm not even going to worry about this circle, okay? The circle is not even dealing with the height at all. What is dealing with this height is this rectangle is 17 feet long. Well, this triangle doesn't go all the way up to the top of this rectangle, so I know it's less than 17 feet. I have to subtract this 7 feet to account for this triangle not going all the way to the top of the rectangle. So I'm going to subtract 7 feet from 17 to just find this dotted line length, and then that would leave me with 10. So just this dotted line would be 10. So half of 9 times 10 is 45. So area 1 equals 45. So if I take all of these and add them together, 1, 2, and 3, and add them together, be 45 plus 153 plus 127.23, and I would get a grand total of 325.23 feet squared. For number 4, I am going to help you out and let you know that you have to draw in this altitude. Okay? So when you draw in the altitude, you're going to have a right angle here. Half of this radius should be half of the diameter. So half of the diameter has to be 8. Okay? So now you have a right triangle. There's a side length that's 8. Here's a side length that's 17. You're going to have to figure out what that is. Whatever your x is, that's your height in this triangle. Okay? Your base would be this 16. Or you could use 8 and then multiply by 2. Okay, so for number 5, I'm going to first divide up this figure into its regions. So the first one I see is this square. So there's 1. Then I see this triangle, there's 2. And then last I see a trapezoid, 3. So area 1, that's my square. So I can use the square formula of s squared or length times width. Okay, and then for area 2, I'm going to have to use 1/2 times base times height. And then for area 3, that is a trapezoid. So I'm going to have to use 1/2 times the height times the bases added together. Alright, so what do we know? What do we know? Let's start with this first let's try to figure out more about this triangle over here, this guy. Because I'm told the height, and I'm told one of the sides, and if I try to figure out this square, I don't know what this height is here. So that's not really helpful. So I'm going to start with this square, or this triangle. So with this triangle, I have two of my sides in a right triangle. So I'm going to probably use Pythagorean theorem. And I want to know what one of these dotted lines is. Okay. If I can figure out what this now black bolded line is, then I could add it twice to find exactly what one of these sides of the square is. So if I think about 9.6, that would be like my A. So 9.6 squared plus, I'm trying to figure out what this bolded line is. And then my 12 meters would be my hypotenuse because it's opposite from that right angle. Okay? So 9.6 squared, I'm going to subtract that from 12 squared. And so I get x squared equals 51.84. Then if I want to solve for x, I take the square root of both sides, and x equals 7.2. So that means this right here, I'm going to erase all this black marker, is 7.2, and this is 7.2. So that tells me exactly what this entire side is. 7.2 plus 7.2 has to be 14.4. So all of these sides of the square are 14.4. Okay, you notice how that was really helpful? It's kind of hard to judge what you need to figure out first. The best way was, like, I started thinking, okay, the square would be pretty easy to figure out. That's one of the easiest formulas. But I don't know what this height is, so I'm going to move on. That's how I kind of thought about which one I should figure out first. So now I can figure out the area of a square. If I zoom out. So area 1. Oh, that didn't zoom out at all. Area 1 has to be 14.4 squared, or 14.4 times 14.4, however you want to think about it. So area 1 is 207 and 0.36. So now I want to think about, we could probably figure out the area of this triangle now, because we have the base and we have the height. So 1/2 times base times height. My base, I'm going to use that 14.4 again. And then my height is that 9.6. Okay, so area 2 has to be 69.12. Okay, last one is part 3. Okay, so I have this trapezoid. For a trapezoid, I need my bases, so I have 10 and 14.4. But I also need my height. So if I draw in this height, my height would be about something like that, and it would have this right angle thing going on. Well, I don't know that exact height. All I'm told is the entire height of this figure, and then I figured out what just this square's height was. So what I can do is I can subtract the square's height from the total height to just have the trapezoid's height. So I'm going to take 25.4 and subtract 14.4, and I actually end up with just 11. So 11 is the height of that trapezoid. So my area formula would be 1/2 times 11, and then my bases are 14.4 plus 10. And putting that on my calculator, I would get 134.2. Now, to find the entire area of that composite figure, I'm going to add up all of these areas. And I get a grand total of 410.68, and we're working with meters squared. Okay, so I know this seems possibly really difficult right now, but just know with more practice, once you just start looking at these shapes more, it becomes more natural to figure out which has to come first. And I'm hoping when we talk about these shaded regions, that might help with a little bit more practice as well. So shaded regions, to find the area, usually this will be like an ACT type question. They'll be like, oh, here's a layout. Find what portion is shaded in the picture. And so you always want to look at the darker part. And what happens is typically you'll find the area of the entire thing, and then you'll have to subtract something. So in 6's case, I would have to subtract this yellow circle. So again, to find the area of a shaded region, find the area of the entire figure, and then subtract the area of the non-shaded region. Okay, so you're going to do number 7, or not number 7, number 6 and number 8, but I'm going to do 7 and 9 as an example. So for number 7, the entire figure is this rectangle. So I'm going to find the area of this entire rectangle, and then I'm going to subtract this white triangle. Jeez, I could not get that word out of my mouth. So the rectangle itself has a length of 14 and a width of 25. So the rectangle area would be 14 times 25. And so I get an area of 350. Okay, and that is the rectangle. Next, I'm going to find the area of the triangle. The area of the triangle has to be 1/2 base times height. And if I'm looking at this, I'm given the height. The height is 11. And then the base is coming from, this is one of the sides of the rectangle. So this side also has to be 25 centimeters, just like it is in the rectangle. So my area formula is 1/2 25 times 11. So the area of the triangle is, in fact, 137.5. Now, to find the shaded region, this is what you're going to do in shape form. You're going to take the rectangle area and subtract the triangle. Okay, and then you're going to be left with that shaded region. So 350 minus 135.5 would give me a grand total of 212.5, and then we're in centimeters squared. Another kind of way to make sure you're doing this correctly, when you're finding area, you should never get a negative area. And specifically for shaded regions, you're going to be doing some sort of subtraction. So if you ever subtract and you get a negative area, flip your numbers. Okay, that means you're subtracting the wrong thing, and you just probably have it backwards. So never get a negative number with area. For number 8, just so you know, this is a right angle. That's something we would have known from circles, from the circle unit, but you might not know that because we didn't do the circle unit yet. So that's a right angle. this would be your base or your height, however you want to look at it. I always tend to use the smaller side, but either of those can be your base and your height because they make up that right angle. The other thing with 8 is you're going to need your radius of this half circle. So you're going to have to somehow calculate this blue side. You should be able, given that this is a right triangle, you should be able to calculate this entire green side and then just cut it in half. Okay, so for number 9, the way we're going to look at this is I have a half circle and then I have a trapezoid. So in my trapezoid, so the area of a trapezoid, that is a bad trapezoid. I need the height and the bases. I have my bases. This would be a base, that would be a base, but I don't have my height. My height would be listed here or here typically, and I don't actually have anything known about this circle, so I'm gonna need to find that height first. Well, what I can do, and this is what I would do this for you on a test, is I'm gonna draw on a dotted line going down on this triangle. So I'm actually making a perpendicular line. What that perpendicular line is going to allow me to do is have a right triangle here. Okay? With that right triangle, I'm going to be able to actually figure out how tall this trapezoid is. And so I know my hypotenuse is 25 inches. I know this entire side is 37, but I really just want this part of the triangle. I just want this part. I don't want the whole thing. So I'm going to have to subtract this almost rectangle part of the entire trapezoid. So 37 minus 17 to just get this part of the triangle, which is 20. Okay. So that part's 20. And then I'm going to figure out what the height is, this x, by using Pythagorean theorem. So I'm going to have x squared plus 20 squared equals 25 squared. Okay. So I'm going to subtract 20 squared from 25 squared to get x squared is 225. Then if I take the square root of both sides, x turns out to be 15. So I'm going to make note of that on my picture. So this side right here is 15. That means this entire circle has a diameter of 15. So that'll come in handy later. Let's calculate the area of this trapezoid real fast though. So the area of the trapezoid would be 1/2 times 15 times 17 plus 37. So the area of the trapezoid is 405. All right, now just looking at the circle, my area formula of a circle is the area formula of a circle is pi times r squared, but this is only half of a circle, so it's actually 1/2 pi times r squared. R is my radius, so that's just halfway from the center to the edge of the circle. So I have to take half of 15. So half of 15 gives me 7.5. So just half of that circle is 7.5. So my area formula for half of the circle is 1/2 times pi times 7.5 squared. Okay? So area, half, is 88.36. Alright, again, a way to kind of cheat. Take your bigger number, subtract the smaller number. But to make sense of that, you're subtracting the non-shaded region from this shaded region. So that should make sense why you're subtracting the half circle from the trapezoid. So 405 minus 88.36 to get 316.64 and then inches squared. Alright, so I know that's a lot, and really this quiz today is not going to be based on correctness. I'm still going to grade you on correctness, but you'll just see when you start to take it. I'm not expecting you guys to be pros at this just yet. But make sure you have at least tried 6 and 8, as well as 2 and 4. Okay, so just 4 problems. That's all I'm asking. Make sure you reach out if you have any questions. And that's all I got. Have a great day.